Are robots really built for war? And can AI push the boundaries of what we think is possible? As tech companies dive deeper into defense, how is the landscape changing? It's certainly becoming more intense and unexpected. Picture this: a humanoid war machine not debuting on a battlefield, but making its first public appearance at a nightclub in San Francisco. This happened with the Phantom MK1 robot, developed by a startup known as Foundation Robotics Labs based in Frisco. Why introduce a war machine at a nightclub, you might ask? Well, the company chose the Temple nightclub for their so-called quarter-of-the-century tech giga-party. At this event, attendees witnessed the robot acting as a DJ on stage. Though it appeared to be performing, the robot's movements and song choices were actually controlled by people behind the scenes. Foundation Robotics Labs was started in 2024 with about $1 million in seed funding. The company's founder, Sanjit Pathak, previously ran a fintech startup called Synapse, which focused on banking services but went bankrupt. After that, he turned his attention to robotics. He teamed up with Mike LeBlanc, a former US Marine who had experience with a security robotics company called Cobalt AI. Together, they aim to create humanoid robots designed for a variety of tasks, from manufacturing to military uses. They are openly focusing on defense applications. Pathak strongly believes that advanced humanoid robots will play a crucial role in future wars, and he often speaks about the importance of the US keeping up with China in defense robotics. According to an SF-Gate reporter, their robot, the Phantom MK1, is truly a war machine. Let's look at the details to see why the Phantom MK1 is called a war machine. It stands about 1.75 meters tall, which is around 5 feet 9 inches, and weighs roughly 80 kilograms or 175 pounds. It can lift up to 20 kilograms, about 44 pounds. Inside, it has advanced cycloid actuators. These actuators give it the strength of hydraulic systems and the quiet, efficient operation of electric motors. This allows the MK1 to produce a lot of power, up to 160 Newton-meters of torque, while still being able to move precisely. Foundation Robotics Labs plans for this robot to do a variety of tasks, from industrial work to home services and even military operations if needed. The upper part of the Phantom acts as the control center, equipped with batteries, processors, cameras, and sensors that provide a full 360-degree view of its surroundings. The company is also proud of how well the robot moves. Its lower body is designed to balance and navigate challenging environments like uneven ground and stairs, and it moves in a very human-like way. This means it can operate smoothly in places like factories, offices, or even areas hit by disasters, which are typically designed for human movement. Interestingly, the Phantom MK1 robot's base technology was acquired from Boardwalk Robotics, a small company in Florida. Boardwalk had developed a humanoid called Alex in August 2024, which was built with a stable base for performing complex tasks. The Phantom MK1 is an advanced version of this, featuring a more sophisticated lower torso for better mobility. Foundation Robotics Labs has big goals. They plan to ship over 40 robots in 2025, increase this to 10,000 by 2026, and then to more than 20,000 by 2027. They're aiming for $1 billion in annual revenue, impressive for a company that's only been around for about a year. They also hope to use the profits to build a base in Antarctica and eventually expand to the Moon, Mars, and beyond. This ambitious approach reflects a broader trend where tech companies are increasingly engaging in defense projects. Even major companies like Meta, OpenAI, and Google, which previously avoided military contracts, are now entering the defense sector. This shift is similar to what happened with Boston Dynamics, which developed the Petman humanoid for the US Army with DARPA funding in 2011 to test chemical suits, and later the Atlas robot for disaster response, which eventually turned to industrial applications. Russia also introduced a humanoid called Fedor in 2016, intended for space missions but capable of carrying firearms. This trend towards militaristic robots is becoming more common as technology progresses. Now let's talk about some exciting developments in robotics and AI research. A major collaboration between Nvidia and Carnegie Mellon University has led to the creation of a framework they're calling ASAP, which stands for Aligning Simulation and Real Physics. The idea is to train robots in virtual environments where they can test their limits without any real-world consequences. This helps to prevent any breakdowns that might occur during real-world tasks. ASAP then helps to bridge the gap between these virtual lessons and real-world applications, adjusting for differences that tend to cause issues once robots leave the controlled lab environment. This system has been shown to reduce motion errors by about 53% compared to previous methods, which is a significant improvement. They put ASAP to the test with a G1 humanoid robot that successfully performed forward jumps over a meter long, quite a feat for a humanoid robot. However, the intense testing led to some problems with overheating motors, which damaged 2 of the test units. Despite these setbacks, the research team remains positive, viewing these challenges as chances to further improve the technology. They've even shared their code on GitHub, allowing other researchers and developers worldwide to use and improve upon their work. In other news, researchers have made significant advancements with the G1 robot, developing a new humanoid motion framework that enhances its capabilities. This framework allows the robot to sit, roll, and stabilize using its entire body, not just the lower half. Traditional control methods for humanoids often struggle with unexpected physical interactions, like when a part of the robot unexpectedly touches the ground. However, the new system, powered by a GPU-accelerated rigid body simulator, can handle such unpredictable scenarios in real time. This improvement enables the robot to adapt quickly to irregular surfaces, recover from falls, and execute human-like movements with a fluidity and precision that previous models couldn't achieve. The goal is to create more dynamic and natural humanoid motion. Switching focus to another innovative player in the field, P&D Robotics, also referred to as P&D Robotics, has been making headlines with their humanoid robot named Atom. Demonstrating remarkable dexterity, Atom has performed complex tasks like calligraphy, showcasing its precise motor control. Building Atom involves a meticulous process that spans about 37 hours and includes 3D modeling and CNC machining. The robot features 37 degrees of freedom and is powered by 20 actuators, allowing it to perform delicate maneuvers effortlessly. Atom's operations are managed by the P&D PMC system, which coordinates 163 CNC machine parts and nearly 400 printed components. The production process utilizes 7 different composite materials and 13 specialized manufacturing techniques, all conducted in-house. As a result, Atom is a highly capable humanoid, capable of handling intricate tasks such as assembling tools or balancing objects. P&D Robotics has also integrated an imitation learning framework with Atom, enabling it to learn locomotion by analyzing human movement data. This development has resulted in a more natural and agile movement, pushing beyond the stiff, mechanical motions often seen in older humanoids. The world of robotics is buzzing with groundbreaking advancements. Foundation Robotics Labs is tackling labor shortages and delving into defense, aiming for the Phantom MK1 to spearhead a new era of versatile humanoids capable of tasks from industrial work to warfare. Meanwhile, Carnegie, Mellon, and Nvidia are closing the gap between simulated training environments and real-world applications, allowing robots to practice in a virtual realm before taking those skills to real-life settings like warehouses or battlefields. P&D Robotics Atom is making waves with its incredible precision and advanced learning capabilities, which enable it to perform tasks with remarkable dexterity. Thanks for joining me in exploring these innovations. If you found this overview intriguing, don't forget to like, subscribe, and stay tuned for more updates on cutting-edge robotics and AI. We're just beginning to explore the vast potential of these technologies, and the future promises even more astonishing advancements. I look forward to bringing you more insights in our next session. Thanks for watching, and see you soon.